Now we are going to discuss about the mid-frequency range. We can see that gain is constant and maximum. So as these frequencies are appreciable, they are very high. In the mid-frequency ranges, your frequencies are quite high. So Xc, which is equal to 1 by omega c, your Xc will be very low. When reactance is very low, what happens is that the capacitors are behaving as short circuits. At high frequencies, this capacitor behaves like a short circuit, this behaves like a short circuit, this also behaves like a short circuit. So there is no potential difference developed across any of the capacitors. So you can see that the entire input voltage goes to the amplifier, gets amplified, and you get a large output voltage. So if output voltage is high, your gain is also high. So you get a high gain in the mid-frequency region. Now coming to the low frequency region, as frequency decreases, reactance increases. So when reactance increases, what happens is that there is a higher voltage drop here, there is a higher voltage drop here, and the emitter current now divides into two parts, I1 and I2. So there is a potential difference I1 RE across this resistor also. So from the input voltage, because of all these potential drops, a smaller voltage reaches here, and after amplification, the output voltage developed also will be smaller. So since VO is less, your voltage gain AV also will be less. So you can see that as frequency falls, becomes smaller and smaller, gain decreases. As frequency keeps on decreasing, reactance keeps on increasing, and your output voltage will again keep on decreasing. So that is why in low frequency range, you get very low voltage gain. Now coming to the high frequency range, you can see that at extreme high frequency range, again these should be behaving like short circuits, but some other factors come into play now. At very high frequencies, there is something called as inter-electrode capacitors. These capacitors, the capacitance between base and collector, we call it as CBC. Between base and emitter, we call it as CBE. And between collector and emitter, it is called as CCE. These capacitors are not physically present in the device, but they are inherently present. They come into play only at very high frequencies. So now what happens is that at these high frequencies, now these behave like short circuits, and they are forming a feedback path for the current to flow back. So we want the entire input voltage, the current to flow here, get amplified and then reach here. But here there is a feedback path, so that causes some of the current to flow back. So naturally your output voltage will decrease. Besides that, all the connecting wires now at extremely high frequencies form what is called as a wiring capacitor. So at the input side we have CW1, at the output side we have CW2. So these wiring capacitors, connecting wires separated by air as a dielectric, they behave like a capacitor. Under normal circumstances or normal frequencies, they don't play any part, but at this extremely high frequencies, they form some capacitor. So at the output side, all these CW2 in parallel with CCE form a shunt capacitor, CS. So now all the current which flows will choose the path of that low reactance of the shunt capacitance. So output voltage decreases. Only the remaining current flows through here. So output voltage decreases. So it is found that gain also falls. Besides that, you can see that beta of a transistor also decreases at very high frequency. Beta decreases at extremely high frequencies. Beta is the current gain. So due to all these reasons, it is found that at extremely high frequencies, gain decreases. So we can see that analyzing the frequency response curve of an RC coupled amplifier, mid-frequency range is the most favorable because gain is constant, gain is maximum. You should not have very low frequencies or very high frequencies for an amplifier, and a good amplifier should have a large bandwidth. Bandwidth is given by F2 minus F1. That is called as the bandwidth. A good amplifier will have a very large bandwidth. Such amplifiers are preferred. So this is the discussion about an RC coupled.